All right, so optimization. This is a suggested strategy for solving optimization problems that I made up. It does not have a nice acronym like DREADS. I challenge you to come up with some sort of memorable or pronounceable acronym for this. But if you do, please tell me. I'd love to hear what you come up with. But anyway, let me walk you through the steps, and then in the next video, I will go through an example using these steps. So the first thing I suggest doing when you approach an optimization problem is to read it carefully and then draw a picture, draw a diagram, and just a rough diagram. It's like if it's a box, then draw yourself a cube, or if there's a circle, draw that. Just whatever's going on, try to draw a diagram and label it with any constants or variables that are relevant to the problem. So then, second thing to do is to come up with your primary equation. Remember, I mentioned this briefly in the last video. The primary equation is an equation for the quantity you seek to optimize. So like in that first example, we were trying to optimize the volume, so we used a volume equation where it was volume equals length times width times height. And for us that was like x times h. So you get your equation for that quantity you're trying to optimize. Then, step 3, get your secondary equation. There should be some constraints. If there's lots of variables floating around, you need some constraints to narrow it down to one variable. Okay, otherwise we're talking multivariable calculus optimization, and we're not learning that this semester. So you should have some constraints, and you can use those to get a secondary equation. Then, in step 4, you're going to take the secondary equation, solve it for one of the variables, and substitute that into the first equation to eliminate that variable you solved for. And then, by substituting and thereby eliminating a variable, you should now have a function of one variable. A function that inputs one variable and outputs the quantity you seek to optimize. Okay? So like in that first problem, we solved the secondary equation for h, and then we substituted that into the first equation, the primary equation, and we ended up with volume as a function of x, right? And the h got eliminated. So that's step 4. All right, so now you have a function to work with. Now you want to, step 5, determine the domain of that function, right? This is where you need to do some realistic, sort of common sense thinking. What is the minimum value that this variable, my now independent variable that I have left over after the elimination, what is the smallest value of that variable and what is the biggest value of that variable? Reasonably, right? Like what's in the real world, what would be the smallest and largest value? You get yourself a domain. Now it's possible sometimes that your domain could be like 0 to infinity. If there's no particular largest value you could have, like hypothetically that length or whatever could be as big as you want. So you might have that be infinity, which doesn't sound realistic, but at least in theory, you could have a length be as large as you want, right? Potentially, in some scenarios. So yeah, I just wanted to mention that. So get your domain, and then you're going to go and find the critical numbers of your function, right? Now we're just doing what we've learned how to do in earlier sections, and take those critical numbers and test for extrema. And depending on the situation, you might use the closed interval method if you have your domain as a closed interval, or if, like I mentioned, if your domain does go all the way out to infinity, you might have to use the first derivative test or possibly the second derivative test. What you're doing is you're just doing some kind of test on the critical numbers you found to determine if they are maximum or minimum values. If they correspond to maximums or minimums of the function. So you need to do that step. What I caution you against is do not just find one critical value, like one critical number, and assume that's where your answer is going to happen, and then just type the answer in and move on. Like, you could do that, and it's true that in a lot of scenarios that actually is going to work. But if you're doing this on a test, I need you to do step 7, which is I need you to show me that you have confirmed that critical number you found is where the maximum is, or is where the minimum is, depending on which one you're looking for. Okay, and the reason for that is if you find some critical numbers, if you find several critical numbers, then you might have accidentally found a minimum when you're searching for a maximum, right? Or you might have found a critical number that is neither a minimum nor a maximum. Okay, you need to do something to determine if it's the right number, and so that's why step 7 is important. So there's a suggested thing you can do. I recommend following these steps. I'm going to do that on the next example, but it's up to you whether you decide to do it or not.